Welcome back. Today we're going to look at section 7.4, which is on the graphs of sine and cosine functions. So we're going to begin this two-section part where we're graphing sine and cosine functions. I will tell you that the questions bank that we have in Hawks does not really prepare you well for the final exam. So we'll be sending you guys a worksheet that you will also be responsible for filling out, and that will be part of your test as well. So when you take your test this time, you will not only do the test that is on Hawks, but you'll also have a certain amount of time to complete another worksheet that will be similar to the one that I send you, also for part of the grade, okay? I will also tell you that when you're graphing these on Hawks, you're more than welcome to use your calculator. We don't spend a lot of time graphing on the notes because, again, you can just plug these into your calculator and kind of pick out the information. So what I'm going through with you today is basically all of the other things that you need to know, kind of to know what your graph will look like, okay? All right, so today, again, we're just going to do the sine and cosine, and then the next section we'll do the other four trig functions, which those get a little more detailed as far as things that you have to do. So for sines and cosines, we just need to remember that these are what are called periodic functions. And a periodic function just means that eventually you're going to see repeated values over a certain interval, okay? So sine and cosine functions, as we know, they keep going around the circle over and over and over again, right? You can go around more than 360 degrees. So that length of 360 degrees, or 2 pi, is the period for sine and cosine. So once you get past that, the values start repeating themselves again, okay? So that's what a period is for these. If you're asked to find the period, that's the length that it takes for the function to repeat. So we're going to be looking for the period in these functions. And then the amplitude of a periodic function is always 1/2 of the positive difference between the max and min values of the function. So we'll talk about that as well. So right now we're looking at finding the periods and the amplitudes. So we're going to start by looking at the basic sine function, the sine of x, okay? So these graphs come from the values that are on the unit circle. So the first thing I'm going to do is just kind of label a couple of things on here so we can start. So I'm going to go and I guess every other hash mark and make that a pi over 4 unit. So we're going to do pi over 4, and we'll go up to pi over 2. Then we have 3 pi over 4. And we'll do pi. Okay. Then we've got 5 pi over 4. And 3 pi over 2 would be next. 7 pi over 4. And then finally back around to 2 pi. So I'm just going to go, just so we can spread it out a little bit so that we can see our points. Okay. And then I know that the sine function doesn't get any higher value than 1. So put 1 there. And it doesn't get any lower than -1. Those are the boundaries. Okay. So when it says the amplitude of a periodic function is 1/2 of the positive difference between the max and the min values. So right here, if I'm looking at the difference between these, this has a difference of 2, right? There's 1 here and then 1 here. So that distance is 2. So half of that distance would be 1, and it would be the positive difference. So the amplitude of this function is going to end up being 1, okay? That's how we kind of look at that. So you figure out the distance between the highest and lowest points. So that distance is 2 again, and then you take half of that. So be 1, and it's always a positive distance. Distance is always positive. All right, so if you go back and look at the unit circle, okay, so let's start at 0. Here's 0, 0. So if I look at the sine function at 0, let's get my unit circle out in case you still don't know it, but I hope by now you know this. So here's 0, and the sine value or your y values at 0 would be 0. Okay, so at 0, the sine value is 0. Now, if I go to pi over 4, okay, here's pi over 4. The sine value is the square root of 2 over 2. And if I go to pi over 2, the sine value is 1. So I'm just going to plot 1 at pi over 2. Square root of 2 over 2 is in here somewhere, but just I don't have that exact value, so I'm not going to plot it right now. Same thing with 3 pi over 4. I know the sine value of that is the square root of 2 over 2, but I'm not going to plot that. I'm going to come down here to pi over 2, to pi, and look at the sine value right here, which is 0. So at pi, the sine value is 0. And then I'm going to go to 3 pi over 2. I'm going to skip 5 pi over 2 again because that's a decimal. I don't want to graph that. So let's just graph the easy numbers right now. So the sine at 3 pi over 2 is -1 down here. And then all the way back around to 2 pi, we'd start where we were again, the sine is 0. Okay? All right, so if I look at the sine curve, it's going to come up, it curves, so I got to make it curve, goes like this, okay? And it's periodic because it's going to keep going this way, and it's going to keep going this way, right? It'll just keep having this same curve over and over and over again. So that's what we call periodic. So from 0 to 2 pi, that's one period. And then from 2 pi, if I graphed it again to 4 pi, I would get that same curve, okay? So I know that the period of this sine function is 2 pi. That's when it starts repeating itself, okay? And I know the amplitude is 1 because it gets no higher than 1 or less than -1. So the graphs of your sine function, all your functions, come from that unit circle. You're just plotting those ordered pairs. Okay, so keep in mind the sine function, those are the y values, right? So if that's, so the square root of 2 over 2 is here somewhere, right? So that's the numbers that I kind of left out. Okay, but they would fall into this curve if we did that. So if you put this in your calculator and made sure you were in radian mode, you would see those values from the table as well. Okay, now if you are going to graph this on your calculator, you want to make your x max, normally your x max is at 10. Well, remember this is 2 pi. So if you change your x max on your calculator to 6.28 or 2 pi, you can just put in 2 pi, then you would see that one rotation. If you go out to 10, then you're going to see a little bit more, okay? So remember, these are radians, these are just numbers, and 2 pi is the same thing as 6.28. So you could set your calculator to 0 to 2 pi so that you could see that. All right, now underneath here are just information that you need to know about the sine curve, okay? First off, you need to know it's an odd function, which we've already talked about, which means f of -x equals -f of x. It's symmetric about the origin because it's odd. Remember, when you turn it upside down, it'll look the same. This up here is just our general function for transformations. So we've already done that, right? A is your stretching and shrinking, B is your stretching and shrinking for x, C, right, that's how much you move left and right, and then D is your vertical shift up and down, okay? So all of those remain the same no matter what function you're dealing with. So you may be asked questions about transformations, so I'm not going to go over that a whole lot because you should already know that. The period, again, that's the length of one complete cycle. In order to do that, you're going to do 2 pi, and then you're going to divide it by the positive b value. B is always the number in front of x, so the period is always a positive value. So just kind of keep that in mind. Okay, and then the same thing with the amplitude. It's always, so it's nice. Remember, we had to count it on the graph, but if you're given the equation, the amplitude is just simply that number out front, a, and it again is always positive. Okay, so your amplitude and your period values are should always be positive numbers. Now the nice thing about your sine function is the domain is all real numbers, and the range, this looks kind of strange, but we're going to do this a lot today, so you'll see you're going to take the d value, which is your vertical shift, minus that absolute value of a, the amplitude, and then just take your d value plus that value of a. So again, absolute value just means that those a values are always going to be positive. Okay, so that's not hard. Just subtract and add from d. All right, so let's look at a few problems. And again, I'm not going to do a lot of graphing today because you got your calculators. What we're more interested in is, can you find these values that we're asking? So numbers 1 and 2 just basically talk about the odd, even, and the symmetry and the period for this. So if you're asked about giving other expressions that are equivalent to a sine value, then remember that the period for sine is 2 pi. So if you either add 2 pi or subtract 2 pi from any sine value, you'll get the same, right? It'll be in the same place on the unit circle. So that's all they're asking you here. Find two other expressions. So I could take 11 pi over 6 and add 2 pi to it. Or I could take 11 pi over 6 and subtract 2 pi from it. Or I could do 4 pi or 6 pi. Any interval of 2 pi, I'll end up back in the same exact place that I was. So if I add 2 pi to 11 pi over 6, I'm going to get a common denominator. So 2 pi would be the same thing as 12 pi over 6, right? That's 2. So that would end up giving me 23 pi over 6. And if I subtracted 2 pi from 11 pi over 6, again, get a common denominator. So 12 pi over 6. So 11 pi minus 12 pi is negative pi over 6. Okay? So two equivalent expressions to the sine of 11 pi over 6 would be the sine of 23 pi over 6 and the sine of negative pi over 6. Okay? Those are equivalent because they are all 2 pi away from each other, and that is one whole period. Okay? Now the next one's talking about odd and even functions. So because the sign is odd, remember that the two, negative f of negative x and negative f of x are equal. So what's another expression equivalent to the sine of negative 3 pi over x, which is this? I could pull the negative outside, and that would be equivalent to that. Okay, so you just have to remember your rules for odd functions. Okay? All right. So we're going to do the same thing now with the cosine function. We're going to look at its graph and then answer some questions about its properties. So I'm going to do the same thing. Here's, oops, I didn't mean to put a point there, 0. Here's pi over 4, pi over 2, which is the one I'm going to graph, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and finally 2 pi. Same thing with cosine. We don't get any higher than 1, and we don't get any lower than negative 1. Don't put that point there. That's a mistake. I'm sorry. I used a pen, so I can't do that. So that point is not there. Okay? Don't put that point on your graph. All right, so if we go to 0, why I messed up already, and I look at, now we're going to do the cosine values, which are the x values. So the cosine at 0 degrees is 1, so not down here, up here. Okay, that's the point. Then again, I'm going to skip pi over 4 because that's just square root of 2 over 2. I don't want to plot that point right now. So I'm just going to go to pi over 2 and grab my whole numbers. So the cosine of pi over 2 is at 0. Then I'm going to go to pi. So the cosine at pi is negative 1. The cosine at 3 pi over 2, cosine is 0. And then when I get back around the circle, the cosine of 2 pi is the same thing as the cosine of 0, up at 1. So this time, the cosine graph goes like this. Okay, that's one period right here. And then again, this thing will keep repeating itself in both directions, right? It'll go back and forth. So the period of cosine is still 2 pi. But the difference is that we started up here at 1, okay? versus if you look at the sine function graph that we did on the other page, okay, it started at 0. So it's one thing you need to remember. They look exactly the same. I mean, if I moved the sine function back a little bit, it would line up with the cosine. So it has the same exact curve. It's just where it begins from at 0. So I always remember, you just got to remember that the sine graph starts at 0 and goes up, and the cosine graph starts at 1 and comes down first. So, you know, that's based on the unit circle and those values. But if you looked at them on your calculator, if you plotted on y1, you put sine of x, and on y2, you put the cosine of x, you'll see they look exactly the same except for, you know, their starting points, okay? So they have a lot of the same attributes, which is what we're going to look at now, okay? But, so we're going to use the same general formula, and none of that changes. The difference with cosine is that it's even. Because it begins at 1, then if you were to fold your paper down the y-axis, the left and the right side would be the same. So that means that f of negative x equals f of x, okay? So that's the difference. Symmetric about the y-axis instead of the origin like sine was. But you'll notice everything else about the cosine function is exactly the same as sine. So that's nice. Find the period the same way. Again, this is always positive, okay? Both the period and the amplitude are always positive values for both of those. Domain and the range would be the same for you to find, okay? So here's the difference. The two difference is that, well, the main difference is that you have an even function instead of an odd, and it's symmetric about the y-axis. All right, but the period for cosine is the same as sine. So to find two equivalent values for cosine of 9 pi over 10, we would add or subtract 2 pi. So just like we did before, we're going to take 9 pi over 10 and add 2 pi. And then we can take 9 pi over 10 and subtract 2 pi. So this time we're going to get a common denominator of 10. So 2 pi would be 20 pi over 10, right? That equals 2. So the positive one would be 29 pi over 10. And then on the minus side, we would do 9 pi over 10 minus 20 pi over 10. 9 minus 20 is a negative 11. So there's your two values. So what two expressions are equivalent to the cosine of 9 pi over 10? That would be the cosine of these two guys. So 29 pi over 10 and the cosine of negative 11 pi over 10. Okay, those are equivalent. So cosine and sine are nice. they all have a period of 2 pi, so that's nice. All right, and then because cosine is even, then we're not going to pull the negative sign out front like we did with sine. We're just going to drop the negative sign. So an f of negative x is the same thing as a positive f of x. So this would be just 5 pi over 13. Okay? All right. Now, the rest of this has to deal with finding the values that we asked in the table above, the amplitude, the period, and the domain and range. So remember your general formula. A is the number out front, B is always in front of x, C is inside with x, D is what's added or subtracted on the outside, okay? So when I'm looking at number 5, all I have is the A value, 2/3, and the B value, which would be 1. I don't have a C or D value, so they would be 0. Okay? All right, so in this problem, A, the amplitude, absolute value, would be 2/3. Okay? B, the number in front of x is 1. C and D are both 0 in this problem. If there's nothing there, that's 0. But if there's nothing in front of x, that's understood to be 1. All right, so the amplitude. Amplitude is the absolute value of A, which we just said was 2/3. Okay? The period is 2 pi divided by the absolute value of B. So that would be 2 pi divided by 1, right? That's already positive. So the period is 2 pi. The domain for any sine or cosine function is all real numbers. Okay, and the range, all right. So let's remember the range. It is brackets on both sides. We're going to go from d minus the positive absolute value of a, and then d plus the absolute value of a. All right, so bracket. I'm going to set this up two ways. So d minus a, so 0 minus 2/3, and then we're going to go to d plus a, which would be 0 plus 2/3. So that's pretty easy. That would be from negative 2/3 to positive 2/3. You just go ahead and simplify that, okay? So there's your range value. So it's not hard, you just got to remember how to get to it. All right, let's look at number 6 then. It's always good to kind of know A, B, C, and D before you begin. So when I write A down, I always make sure it's positive, right? So A, in this problem, even though A is really negative 4, I need the amplitude, so that's going to be 4. B is the number in front of X, which is 2. Okay, I still have no C and D value. We'll get to those on the next page. All right, so the amplitude, absolute value of A is 4. The period is 2 pi divided by the absolute value of B. So that would be 2 pi divided by, in this case, B is 2. So now the period shrunk. It's only going to take you half the distance to get through one complete cycle. So if you look at this graph, well, it's the sine graph, but if you look at the sine graph, instead of taking to 2 pi, we're going to go from here to here would be one cycle. So it would kind of go like this. It would come here and then go there. So we just shrunk it, right? Only took half of the time to get all the way around. That's what that period is telling you. Okay, so if we were to graph that, it would only take us up to pi to go one complete cycle. All right, the domain, all real numbers. And then the range, so far not too hard. We're going to go from d minus a, so 0 minus 4, to d plus a. Okay, so the range would go from negative 4 to 4. Okay, so there's your range. All right, so those are just kind of the basic ones. Now we're going to look at a few that now have C's and D's, so we got a little bit more to do. All right, so again, I just wrote these up here just so we don't have to keep going back to the other pages. So remember your standard form for your transformations. So the phase shift. Okay, so this is a little bit different wording, but the phase shift is exactly what we did with transformations, which is the horizontal shift, how much the graph moves left and right. But with trig functions, the period affects the phase shift. So it's not just going to be the opposite of C, it's going to be the opposite of C divided by B, okay? So that's the difference with trig. You have to do your horizontal shift revolves around both things in here, okay? So it's still the opposite of C, like always, and then you have to divide that by your B value. The vertical shift, how much you go up and down, that's the same as it always is. It's the same value as whatever D is, okay? Now, sometimes when you get an equation, and Hawks is known for this, they're going to put the D value out front. Let's see if I gave you one of those. So I did not. Okay, so we'll go through that in a minute when we get to that first problem, just so I can show you what it looks like. All right, so now we're going to do the exact same thing we were doing. We're going to state the period, the domain, the range, the amplitude, and then we're going to add the phase shift and vertical shift now. Okay? On the last page, there was no phase shift and vertical shift because there were no values of C or D, right? So we'd be doing 0 over something, and this would be 0. So that's why I didn't ask you those on the front. But typically, you're going to go from an easy problem, like the ones we just did, to ones that have a C and D value. All right, so again, looking at this, let's make sure we see in our problem that A is the number out front, which is 1. B is the number in front of x, which is also 1. Now we have a c value of pi, and then we have a d value that's 0. Okay, so you need to write those down. Okay, so we're going to find the period, the amplitude. I'm actually going to write the amplitude first. Okay, then we're going to do the period. Then we'll do our domain and range. And then we're going to do the phase shift, which I'm going to label PS, and the vertical shift VS, okay, just so we can abbreviate. So we've got the phase shift and then the vertical shift, okay? All right, so that's what we got to do for all these problems. All right, so the amplitude is the absolute value of the number out front, so just 1. The period, 2 pi divided by the absolute value of B. So B in this problem is 1, so 2 pi divided by 1, which is 2 pi. Domain, I don't have to think about it, cosine, all real numbers. The range is going to go from D minus A to D plus A. So D is 0, A is 1, so 0 minus 1 to 0 plus 1. So that's from -1 to 1. All right, the phase shift is the opposite of C divided by B. Okay, negative C divided by B. All right, negative C would be the opposite, so positive pi divided by B, which is 1. So we would go pi. So that would be right pi, right? So that makes, supposed to be left, but we ended up going right pi. Vertical shift is whatever D is. So in our problem, D is 0. So we're not going to go up or down any. Okay? All right. So that is our steps to finding these. So they're not hard to find. You just got, it's a lot to remember. All right. So look at your values. A, 3. B is 1. C is pi over 2. D is 5, right? So those are in order. Now, what I was telling you is that, let's look, another way that you could see problem 8 on Hawks would be they would write it this way. Same exact problem, but a lot of times they like to put the D value out front. So that does not make that A, okay? A is still the number out front you're multiplying. B and C are always in here. So every now and then you're going to see a problem in Hawks where the number is out front. So please keep that in mind, that that's still D, okay? That's what's being added or subtracted to the problem. That's your vertical shift. All right, so we've got the amplitude, absolute value of A, which would be 3. We have the period, which would be 2 pi over B, and B is still 1, so that's just 2 pi, right? 2 pi divided by 1. The domain is all real numbers. Sorry, my voice is a little cracky today. We have the range. All right, this time we have a D value. So we're going to go from D minus A to D plus A. So 5 minus 3 to 5 plus 3. So that's going to give me 2 to 8. Okay, so that's your range value. All right, then we've got phase shift. So I'll keep writing that formula for a little while. Negative C divided by B. So the opposite of C would be negative pi over 2 divided by B. B is 1. So we get negative pi over 2. And then the vertical shift in our problem is D, which is 5. So that means this graph is going to shift up 5 units. Okay? All right, number 9. Look at your values. This time we've got a B value, so it's going to change a little bit. So A is 2, B is 2, C is pi over 4, and D is -1. Well, C is negative pi over 4. We're going to change that sign in a minute. D is -1. All right, so the amplitude is 2. Your period this time, 2 pi divided by b, remember? So 2 pi divided by 2. So our period has shrunk again on this one to just pi. The domain is all real numbers. And the range, d minus a. So d is -1 minus 2 to d plus a. So that goes from -3 to 1. Okay, to simplify that. Your phase shift, remember, is the opposite of c divided by b. So that would be positive pi over 4 divided by 2. Now, you gotta be careful. When you're dividing, remember, that's the same thing as multiplying by the reciprocal. So that's pi over 4 times 1/2. So pi over 4 divided by 2 is pi over 8. It is not 2 pi over 4. So you guys need to be careful with that. Okay, watch your division. All right, and the vertical shift. Okay, that would be your d value, so that is -1. Okay. All right. So, they're getting a little bit harder depending on the values that are in there. So we will keep looking at those. All right, so let's look at number 10. Look at your values for A, B, and C. A is 1. B this time is -3. C is that pi value, and D is 4, right? All right, so we're going to do the amplitude, which is just 1, number out front. The period, 2 pi divided by the absolute value of b. So that would be 2 pi divided by 3. Okay, again, the period is always a positive value. B is, you're going to always use the positive value. Okay, so 2 pi over 3, that is reduced. So there's the period. The domain, all real numbers. And the range, it's going to go from d minus a, so 4 minus 1, to 4 plus 1. So that's going to be from 3 to 5. Okay, phase shift, -c divided by b. Okay, so the opposite of c is pi divided by b. Now, this time b is -3, so we are going to use that. Remember, we don't do the absolute value of b here. So b in this problem is -3. So our phase shift is going to be -pi over 3. So that's a little, you got to be careful with that. For the phase shift, you always do the opposite of c, but whatever b is. The only time you use positive b is in the period. Okay? So this phase shift is going to go -pi over 3. Then your vertical shift, that's the d value, so that's just 4. Okay? All right. Number 11. A is 2/3. B this time is pi. That's different, but that's b. C would be 2. D would be 3, -3. Okay? All right, so the amplitude, absolute value, 2/3. The period, 2 pi divided by the absolute value of b. So that is 2 pi divided by pi. Okay, you can get that, so don't, sometimes it's going to be pi. Remember, that's just a number. So the pi's are going to cancel out. So this time the period is 2. Okay, the domain, all real numbers. The range, remember, goes from d minus a to d plus a. So -3 minus 2/3 to -3 plus 2/3. You got to do a little work here, or just use your calculator. -3 is -9/3 minus 2/3. That would be -11/3. And then -9/3 plus 2/3 would be -7/3. If you're not liking adding fractions, just use your calculator, okay? Don't miss that because you can't use calculator, so do that. Phase shift, -c divided by b. So the opposite of C would be positive 2 divided by B, which is pi. Can't reduce that, so that's fine. Okay. And lastly, the vertical shift, whatever that D value is, so negative 3. Okay. Okay. Last one, number 12. A is 4, B is 5, C is that pi over 3 number, and then D is negative 6. All right, so amplitude, positive 4, period, 2 pi over absolute value of B, so 2 pi over 5, can't reduce it. Sorry, that's my dog barking. All right, the domain, all real numbers. The range, D minus A, so negative 6 minus 4 to negative 6 plus 4. So that goes from negative 10 to negative 2. Okay, phase shift, negative C divided by B. So that'll be pi over 3 divided by 5. So again, what does that equal? You guys got to make sure that you can divide that correctly. So remember, dividing by 5 is the same thing as multiplying by 1/5. So that'll give you pi over 15. Okay. And the vertical shift, that would be negative 6. Go down 6. Okay. All right. So that does it for this section. Again, sorry about the dog. At least he waited till the end of the notes. So make sure that you can do this. And again, when you look on Hawks, you're going to be asked about maybe some graphs. So use your calculator to help with that. I'll talk about graphs again more in the next section. But more importantly, that you can do this. And again, you're not going to be asked some of the, like the domain and range and things are not going to be in Hawks so much. So I'm going to be sending you guys a worksheet so that you can practice on that as well for your test, okay? All right, so keep working. Let me know if you have any questions.